How's it going, guys? Matt here for Code Tech Tutorials. We're going to be doing a little decorator demo, just kind of a custom secondary one to maybe go after the first episode if you just want an example of, well, I guess it's just going to be me making a decorator out of some kind of interface. So I'm going to make Decorator 2 folder here in the project and add to our CMake under design patterns just to add subdirectory of decorator 2 so we get that project added in. Then we'll go to it and we're going to copy in one of these CMake lists, change it to deco 2 I suppose, and delete all this extra stuff. We still do want a main, but we'll see what else we end up with here. Of course, the main is going to be the main entry point as expected, but we want to work up a little example. So what I was thinking here is, well, we make an interface for something that you might use in a game, because that would be a pretty common use case if you're using C++ for making a game. And there are a lot of things we could do here. I thought about, we could, for example, decorate up a character or a monster or just an item, and there's a lot of stuff like that. So maybe we'll work with item. So what we want to do here is basically give the item an interface, and then from there we'll add some kind of components you can add to it, and we'll decorate those up as needed. And as you'll see, this will make the item very extendable in the future, because you start out with the base interface class, and then you can make decorators as needed depending on how you want to expand the item. All right, so let's go ahead and make a new file, and we'll just call this just item.h. I think is fine for now, and we'll include it in our main because we are going to use it at some point. So for sake of visibility, we're just going to display stuff in the console. So we're mostly going to be using strings, where, as in a lot of examples, you might have more than just strings, or a lot of real life examples, such as you might have accompanied meshes and stuff like that that could change too. So keep that in mind for gaming type stuff. All right, well, let's dig in. So we want an item. First of all, this is a header. So let's put our pragma once up here, and let's make an interface for an item. So just stick with structs for now. Let's make it a class, and we'll call this, I suppose, just base item. And we want to make sure this is pure virtual. So to do that, let's make, first of all, a virtual destructor. Don't forget the squiggly. And then we just want this to equal default. And then we want some kind of pure virtual function here to kind of say what it actually is, or, you know, to make sure it's an interface. So maybe we want like a get. I like having get name here, and we'll just have it return a string. That way you can just get the name of the item. Set this equal to 0. Make sure it's an interface. And of course, we'll have more stuff as we go, depending on how we build this up. So we probably want a few basic things. Now there's a lot of thought that can go into this. We could put damage on it. We could put little special statistics and stuff like that. So we need to basically decide the root cases of what an item is in this particular game or example. And I want to keep it simple. It's going to be very easy to expand deeply quickly. So let's talk briefly about what you'd normally do if you weren't using the decorator. What you would do is you would basically just extend this endlessly for every option you have. So say, for example, we have a weapon. It would implement from base item. Now let's just not call this base item. Let's just call this item. It would implement item. And of course, we'd have to implement the pure virtuals, which we can do here on Visual Studio, except it just gives you the option but doesn't actually work. Thanks, Visual Studio. You mind fixing that? Would be great if you would. So we do need to implement this get name. So what we would do is the same thing. Virtual string get name, and we'd return the name. So we could have that private. I guess it'd be better to make it protected in this case, if every item has a name. So it would be something like that. Since everyone's got one, it's fine here. We can just get rid of private. We're not really going to use that yet. So there we go. We have a weapon. It implements what it needs to, but it's not really a weapon because it hasn't changed enough stuff yet. We would say something like the weapon needs more than that. Like it would need some damage. Oh, and this should be override. And this should also probably be const. Const because get name is just a getter, it doesn't change anything. And this string could also be const, but whatever, we'll just leave it how it is. I think I'm spelling virtual wrong. There we go. Now there's no way to actually set the name either. That's kind of a problem here. So when we make this implementation, we need to make it so you can set the name like so. And actually we could just do that even in a more cascaded fashion by putting that in this root one like so. So that automatically gets implemented into any of these classes that implement it. And we no longer need this exactly, but we still need to forward this somewhere. So we would have to do it something like this. That way we can forward it along to the item constructor. And that's the only way to change the name. But it's not a weapon if it doesn't at least do some damage, right? So let's get that in here and we'll just make it an integer, protected integer. So this would actually be the weapon decorator. Well, this would be a weapon. Okay, we haven't got to the decorator yet. This is how you would normally do it without the decorator, what we're doing here. So we just need to add in damage to this constructor as an integer. We'll just call it D, and we'll set damage to that. And just like that, we can now instantiate a weapon and give it a name and some damage. We probably want a method to get the damage. And if you're working with all public, then you don't have to worry about all these getters, but just kind of trying to follow the best practices here. This one doesn't need override, of course. We could make this virtual just so other people can override it. And there we go. We can now instantiate a weapon. So that's the normal way of doing inheritance. Right now we could go weapon. I don't know, call it something. We'll just call it weapon 1. And we're offered 3 constructors here. As you can see, we're offered a copy constructor, a move constructor, and the one we implemented ourselves. We need to know about string here too, otherwise that's why it said error type in that one pop-up. So let's include string since we're using it. We could use const char stars, but then we'd have to worry about managing memory. The string will just do that for us, so we might as well take advantage of the features we have. We're going to use the one we implemented. Now, if you don't want the move ones to be allowed, you can just delete them. So you can go something like this. That equals delete. And then the same with the move one, which looks like this. So if you delete those, now when we go back to our main and we go to build this, you'll see that those options aren't even there anymore. So that's just a C++ thing. But now let's go ahead and give this a name. We'll say I don't know, call it a basic sword, I guess. And we want some damage. I don't know, how about 3? And that's what it'll be. Standard, cout. We'll just go weapon 1 dot get name, space here, and damage. And then we go weapon 1 dot get damage. Now you'll notice that it didn't have much help for this get damage. New line there. But we do have it implemented here, and it's not pure virtual, so it should work just fine. Let's go ahead and give this a run. So, yeah, and you can imagine, oh, I spelled virtual wrong. That's all it is. Spelled string wrong, just a few little errors. Now called just item. There we go. Okay, fixed all those errors. Now we should be able to run this. Let's look for Deco 2. That's what we named it. We might as well put it in release. Let everything recompile here. And hit play. So CMake was kind of automatically done in the background. Oh, we have a error with string here. Oh, an error with cout. We just need IO stream here. We're going to use cout. So let's go ahead and try that again. And we get our basic sword damage of 3. So that's generally how you would implement stuff without the decorator. And you can expand as needed. If you want another special type of weapon, you would go class, I don't know, whatever it is. Maybe you would implement types this way, like you would have a sword weapon and an axe weapon and all kinds of stuff like that. And it could just go on and on. But this would implement or inherit from weapon. So I'll make a quick example of what that might look like. So we'd have all these functions already, but we want to make a new constructor for magic weapon and add some new properties, like int magic damage. And make a constructor here. And we want to do the same thing, give it a name, default damage, and magic damage. Call that one MD. And we do this basically the same thing. We just forward this one to the weapon constructor with N and D, which will then forward it down this line and take care of that. And then we'll have our own magic damage, which we need to construct to this MD. And that would be it. That would be the whole implementation. But of course, now the get damage is different because it's going to add the magic damage. So this we would want to override. Something like that. So we'd override the get damage if it's a magic damage to, or if it's a magic weapon, to include the damage plus the magic damage. And now we've extended it further and we can implement that one as well. I'm just going to copy these lines down. Call this magic weapon. Call this weapon 2. Call this magic sword. It needs one more thing here. Say it does 2 magic damage there. And we call the same function, and let's give this a run. So we should see a new item here. And we see the damage it does is just 3 with the magic sword. Now, why is that? It's because we haven't changed this to the new weapon. We're calling get damage off the first one we created, so of course it's 3. So let's update that. Coding correctly helps. And there we go. We see the magic sword does 5 damage as intended. So as you go, you could do this. And this pattern just goes on and on. You make yet another class for your next special type of weapon, and so on. And eventually you end up with just a massive hierarchy of tons of different things. So this is where you might decide, all right, this is getting like crazy. I have so many different classes for every little specific thing. This is when you introduce the decorator, if you see this sort of thing happening. So you'll be able to save a lot of lines of code if you basically just have a few of these and then just make what you would call extensions. And I will go ahead and show you how to do that in a dynamic way. And with these extensions, the great thing about them is on the fly, you can add, remove, change them and stuff like that. So in this case of a game, it might be great for if you're enchanting or repairing weapons, and I guess it'd be more for like enchanting or adding properties, and maybe you can remove properties and put different properties on, standard kind of enchanting stuff on like Skyrim or some RPG or something. This initial setup, it works great for kind of static weapons, but we'd have to add functions to change things, which we could do, but it might be better if we just have, the root item, and then we have it set up how we want, as in decorated how we want. All right, so let's change this code. Well, we have some options for how we want to do this, and keep in mind that there are drawbacks to doing this, as there are with any of these things. So, like the advantage of this whole weapon and an extending weapon to magic weapon is you could have a weapon slot and you could put a magic weapon in it if you're using pointers. Once we go to this other pattern, it becomes a little different, so keep that in mind. So I think the first thing we want to do here is, well, this is actually okay, item, and then we have a weapon. I find that to be okay, but what we want to do further on, rather than extending weapon in this magic weapon, is extend item once again here. And this is where we would add some properties. Instead of adding the whole magic damage thing here, what we would do is instead have a pointer to a weapon. So we want to pass a weapon into here to magic up, essentially. So what we would do here is go, this should be just an item. Now, this is where it gets a little weird, because this is a pure interface, right? We're inheriting from it. But since weapon is an item, we could pass in weapon, or we could pass in anything. So it might actually make more sense just to call this magic and then work with it from there. So now what we have to do here is basically make special constructors for magic and have them work off of any of these decorators. Like this is basically an item decorator, this weapon here. So this magic, we want to take item pointer here, but how do we know which one it is? And this is where you might need to do some planning, because, well, you could say you got to give it an item, but you can't give it this default item because this one is not allowed to be constructed. It's pure virtual. So it's got to be something that implements it. We got another thing in here for the magic damage, because this is magic. Well, let's just call this one item here. So what we would say here is we now construct an item, but the item has no default constructor. We need to decide, well, which one are we actually working with? So in my case, I'm going to keep it pretty simple here. I'm going to make this second one just a mod, because this is essentially a magic item. What type of magic item depends on what item they ended up passing into here. But essentially we'll say our item, well, let's give this one a different name. Item underscore. Item underscore is going to be our item that we passed in. And then we want to give it the mod. So what is this mod? It would be basically our magic modifier. Let's just place that as an int and call that magic modifier. So it really depends on our design, really, but essentially we want to set the magic modifier to this mod. But, you know, we're designing a magic system, essentially, and this is very bare bones. But we got to give it some item to be magical, and what the mod would be is basically what I'm thinking here. So then we just pass in that mod. So what we want to do here with this magic decorator, I'm considering putting the decorator keywords on these. I don't know, though, but it doesn't necessarily matter a whole lot. It's more important that the you wouldn't normally do that if you're coding, is the point. You normally just kind of do the thing you're doing, and you don't necessarily call it a decorator. It's what it's known as in the programming world. Okay, so we have this magic, right? And it inherits from item, just like this one. We've got an item pointer protected here. We don't have that in weapon, obviously, because a weapon can fill out an item, and a yeah. So this would be like the concrete class, I guess we'd call it. Concrete weapon. I guess that would be, yeah. And by concrete, they just mean it's an actual instantiation. So I guess we'll name it that just to kind of simplify a bit. There we go. And so now when we make a concrete weapon, you pass a string and the damage, and that's it. But if you want to make a magic weapon, you got to put the item in there, and you basically modify it with this magic. We got the magic modifier there, and now if we want to override get damage, so it'd be like virtual int get damage. Well, we can't override get damage, actually. Doesn't really make sense. We just need our own get damage, and this, yeah, it doesn't necessarily need to be virtual. So int get damage const, and we want to return, well, we can't necessarily tell that the item has damage. Damage is a weapon property, right? So that's where it gets a little tricky here. That's where you need to decide whether you want to do the casting or not to get the proper values out of this. Also, it doesn't like this constructor, this magic constructor, because if you hover over it, it'll say item has no default constructor. So this item doesn't just work so easy with no default constructor. So we'd have to put one in here, is what we'd have to do. So, well, we have the name. You know, the name is kind of something we want on every item, but we could do this differently. So we could make it a little more simplified, make it unnamed, so to speak. So we could just go item and just have it this equal default. And then this should be happy. Thing is, it's just not going to get a name. So maybe we want a void set name that gets instantiated. But do we want to mess with that? Do we want to mess with giving people the ability to change the name? That's something you have to decide for any of these, and I think it's fine. So we might as well put it in here. And we should probably make this let's just make it copy. It's going to be inefficient, but at least we know who's owning the data there on that set name. And it's us. We copy a new one that we own of the name, which might be inefficient for what you're doing, because if you only ever set this name once, maybe a move operation would be better. But we're not going to get into that for now. That's more of an optimization. All right, so now this is happy, but it doesn't set name. So we'd have to call something like item dot set name, and we'd have to give it whatever name we want. So we'd have to pass that in here somewhere, basically. So we don't have a name right now, so we would just go through that. Now, we are going to have an idea of in our own program which of these concrete classes we have and which of them can have this magic applied to them, because we might also have, let's say, for example, concrete armor. So we're going to stick with a dynamic way of doing this. And instead of damage, it's going to be damage resist. Just keep it simple. And we'll call this one DR. DR. And just like that, we have a weapon and we have a concrete armor. So the point is, you can have as many concrete ones as you want. Since they're all items, we can apply this magic to any of them and this modifier to any of them by just using this here, this magic decorator, what we would call this one. And we would want all this magic decorator's operations to go off this item. And we could, this is how, things get a little interesting here. This is where we need some helper classes to do some casting checks and see what we have. So we know we have armor and we have weapons. We know that those are valid types. So we probably want to make an add-on here, just like a private function that operates specifically in this magic decorator. We could make it even a lambda. We could go auto. Let's think about this here for a second. If we want to detect what type it is, well, we got to design that. So got to go in the think tank a little bit here for a moment to think about the best way to do this. But basically, it'd probably be with something like an enum that has all the different types listed ultimately, or something like that to accompany your concrete types. Because essentially what you want to do is have it be able to check which one it is and return that. And then just have a little switch statement that maybe figures that out. Just some accompanying framework. So I guess we'll just type that up real quick. We'll just have an item type. And we'll have an unknown if it's not set. We can have armor. We can have weapon. And that's all we have right now. Now this is just a declaration of this enum type here. It doesn't really do a whole lot else other than that. We need the function to go with it. So we could go something like, just declare a function that returns item type. And let's just call it, what is item type? And what do we pass in here? We pass in an item pointer. And this is where we want to do the cast check. So we do a switch on the item, or well, not a switch. Switch would be inappropriate for this actually. We would do a cast check. So we would go like auto armor. I'm trying to think of a great name for it so you know what it is. Cast to armor equals dynamic cast to an armor or concrete armor pointer. Then we pass it this item. So if this succeeds, we know that the cast is correct. Now I think we actually need a pointer here. There we go. If the cast to armor is successful, then we want to return item type armor. I think that'll work. And then we, so we don't go any further if it's armor. So we also want to have a weapon here. Call this one the cast to weapon. And you could kind of define this structure as needed. And then if it gets to the very end, we will just return item type unknown. Now let's see if this actually works. This is kind of weird to instantiate an enum like this. I don't know if it's actually going to see it as a proper item. So we'll see. We are on C++ 17, I believe. I think we haven't actually specified, so it's probably given us 14. I think that's the default here, even though we have this. Let's see. Okay. If our CMake version is greater than 3.12, we try C++ standard 20, because I guess that's where they started supporting it or something. That's in just all our little CMakes here for all these little properties. Actually, we forgot to rename these targets in all of them, so I guess that's something I'll fix while I'm here. We did it in factory, and then I just never changed it. But it doesn't cause any errors because it's not that. I'll change that one. So we'll just go through and do this real quick, make this fix for these, and then we'll get back to our work here in Decorator 2. And save all, close all of these. All right, well now if we go back to our main, this no longer works. We don't have weapon anymore. It's now concrete weapon and magic weapon. So let's try our new example. Concrete weapon takes a name, takes a damage, and then we want to make a magic concrete weapon. So we give the magic type, call it magic weapon 1. And this one needs something to identify with, a pointer. Well, since we didn't declare it as a pointer here, we got to put the reference in front of it. And what did we spell wrong about magic? Let's have a look. Magic decorator. And it also wants the magic modifier in there as well. Let's say it's a 2, or like +2. Now, magic decorator is an abstract class here. That's part of the problem. So we definitely need to implement this getName method, like so. And this should now return a proper name. So we could put armor or something like that on the name, because this could have, yeah, I guess we just say what it is. That's probably going to be the easiest way to do it. And this is where something like using our helper function here, what is item type, will help out a lot. So we can go something like, well, let's use a switch statement, and we can use it on item type. We need item type though, so let's actually declare one in this function, auto. Well, we can't do it as auto. Let's go item type, this item type, and we'll set that equal to whatever this returns. So we'll use that function equals, and then we pass in the item pointer that we've set, which is right here. So we basically, this will handle the casting and return the right type. It'll set that, and then we can switch on this item type and do maybe a C out in different cases or something like that. So this gets a bit ugly, but you kind of get the point. I wish there was a way to quick fill these cases out, because it's just the same thing over and over. Item type farmer, item type unknown. So there are different ways to work this up. We could have like a part of a string being filled out by the switch statement, and then have the standard C out at the end, or the return at the end rather. So it probably makes sense to make this some sort of string builder here, which you could abstract out further if you want, but basically we want to return whatever it is in this case. So, you know, the other way I'm kind of thinking of doing this that would be good is, if you have an elaborate name, you might want your string being built as you go through these getName functions, is the point. So just to say that there are options. I know you guys don't always like options. You're just like, tell me how to do it, don't give me options. But the reality is, options are good, even if they are confusing at times. So essentially this just does a quick little string converter type thing. And there we go. We'll return unknown on the default too, which shouldn't happen, but we want to future-proof it a little bit. If we add to the type and forget to update this, maybe we'd even make this unhandled. And since this, well, yeah, so we abstracted a lot of the code there. We could even abstract this further and have it return the string like so, or we could make an override of this where it's the exact same function, but instead we return a string. We could use either and just have it directly return these. That would save us some lines of code. So yeah, let's just do that. So you can't overload by return type. Yeah, so I guess in some way or another, we'd have to change this a little bit. What is item type? Let's make this one say string. What is item type string? This one will just be what is item type. So yeah, you could choose one or the other and not do both of these, you know, in reality. But if we're going to do this sort of thing, we might as well make it more simple. Just do this. And there we go. That cleans this up a lot. You know, and you can imagine that this sort of function is more of a utility. It might be used in a lot of different places in the code. That's why it might be a good idea to separate it out rather than have it right here in the function. Because chances are we're going to use this getName somewhere else too. So that's how we do the casting and figure out what type it is with this magic decorator. And that's how we could go even further with it. This item class doesn't have a get damage, but we have a get damage and these weapons. So that's something that's another thing we have to think about. Now, do we put the damage in the item, or do we have these stay separate as they are? So we don't actually want these to be overridden, I don't think. But it gets a little weird here because, well, we probably want another front end here, like on this magic decorator, something like int get magic mod. Well, this could obviously just return the magic modifier. So, and that would just handle it so we could abstract it further wherever we're using the code. But anyway, and we could say if it's a, we could do a little string comparison on this return, which is slow. It's going to be better to do enum comparison rather than string comparison. So that's kind of why it's best to have both of these. But if you're wanting to print line or get the string, so for some reason for your interface, that's when you want this one. If you're doing comparisons, it'd be better to use this other one. So that's the thing. So get name assumes you want the string, and that's kind of it. But in this magic mod, we might want something else. We might want to trying to think here what would be best here. You basically want to be able to call functions from the armor and the weapon, and that's not necessarily super obvious how to do that here, because sure we have a pointer to it, but we need to get the casting to see what it is. So that's basically what we'd have to work in. So this example might seem a little convoluted at this point, and to be fair, it kind of is. Now, what you probably want to do from here is like really think about how you're actually planning on using this. In this example, it's just like a whatever example. So I don't necessarily have a plan on how I'm going to be using it, which sort of makes it difficult to design. Because typically you think about, okay, what do I want? What do I need for my game or interface or whatever I'm doing? And that's what you design. In this case, I'm just kind of like showing you random examples. But you can see where you would go for here. But you want to get to the next thing. So look at this, let's look at this example and think about how we could do this. All right, so we've decorated up a weapon, gave it some magic, and we can call on weapon 1 any of those base functions. We can call on magic weapon only the stuff from magic decorator, which of course we still have the get name, so that'll work. And it should be a little different. So if we call get name here, we should get a blank because it's blank. But if we call get name here, we should get its type. So we should probably call this function something new like get name or get type. And we're getting back into that get item type as string. So get item type string might be more appropriate. And then we could just have the actual get name. Let's do that virtual. Have it return item name. Oh, we'd have to like build this up. Let's just do a string here. Call it item get name. We're going to be doing a lot of copying here. Very inefficient, but plus equals space plus item get item type string. Well, you wouldn't need to call this on item. You would just call this like so. It handles all that automatically. And then you would have this name string to return. So we're calling the root one here. That'll get whatever we set the name is as. And maybe, I don't know, maybe we want this bracket thing, say whether it's armor, like to the right of it, or something like that. Okay, so let's give this a little try. So we know on weapon, it's probably going to display blank. We actually need to call set name here. Why is this thing complaining all of a sudden? Oh, we need to override get name here. Const override. There we go. Now it's happy. So on this original one, yeah, we need to say something about it here. We need to set the name basically. We don't, well, I guess we do it right here. Yeah, let's just see what happens here. Get damage should be magic weapon. Now this doesn't work, right? 'Cause that function isn't there. So instead we have to get like the magic mod. And we have to add that the weapon that's in it. Now this is where you would need to check casting and design careful functions, because you would be like get damage plus. Okay. So we add those together, the damage and the magic mod. So you would have this somewhere deep in your game logic. And as you can see, we now need to track 2 objects. But here's the thing, and here's where like flyweights come in. You could use this same weapon all the time, especially if it is const. Like so. But then this doesn't allow const, so you got to think about that. I guess maybe you don't want it to be const then. All right, let's give this a run. We should get the first name and damage, basic sword damage. Then we got basic sword unknown. It shouldn't be unknown. Where we getting unknown from? This get name. Oh, we're saying get item type string. it should pass one of these and work. So let's put a breakpoint here and put this in debug, give it a run. And we'll see it gets here, attempts to cast the armor, which should be wrong. So this should be null, still null, okay. But it is a weapon, so this should not be null. But for some reason it seems to be, oh, I'm trying to cast it to armor again. Whoopsie, so a little error in the code there, no wonder. All right, so let's stop this and rebuild it, and we'll go again. We can take this breakpoint out, it should work fine. And there we go. And we have a basic sword that now says weapon. You know, we should put magic on there if it's magic. Right here on this get name. See, we're building up the string. We should start it with equals magic. And we'll see, we can really work this up, this name, to be as specific as we want. So it'll be a magic, the get name, and then, well, thinking how we want to do this. Let's start it out with the name, and then on the second part, that's where let's put all this together. It'll be a magic. Well, I guess we can combine these now, like so. It'll be a magic, and then the item type. That's the name string. So let's give that a run, see how that looks. Magic weapon, cool. And we could go further here. We could put the magic mod on there. We'd get this magic modifier as a string and put it on there. So we probably want it after magics, like magic +1 armor or something. That's how I see it anyway. So let's do that right here, our string builder. Let's go to string, I think is the function. Put in here magic modifier. Is it standard? Yeah, okay. That should work. So let's check that out now. We need another space in here somewhere. Put a space right there. And we also need like a plus or a minus. Now these can be minus, that's the thing. So we need to decide here. We could do an inline thing to put a plus or a minus. Let's do that on a new line just for simplicity's sake. So we'd want to switch on, let's see, if magic modifier, if it's less than 1. Well, if it's less than 0, we'll say, then we put a minus. Well, we return a minus. So let's put a little minus symbol like that. Otherwise, we are going to return a plus symbol. So this kind of brings up the point of, what if you pass in 0 as the mod? Is it still magical? Is it going to get plus or minus? We could very quickly wrap this in another quick if. Say if magic modifier not equal to 0. So that way it's definitely plus or minus, it's not 0. And it'll just skip this entirely, not put any symbol if it's 0. So that solves that little graphical glitch that could come up. Here we go, we got basic sword, we got magic. And the thing is, when you make a magic sword, you probably want to rename it something else. So you would call magic weapon 1 set name. Yeah, .set name, and give it a new name of like, I don't know, Armageddon +2 sword. Oh, I'm doing this entirely wrong. Gotta pass it into the function. We're not writing a function. All right, so let's go ahead and do this. So it's based off that basic sword. What, this set name didn't happen. Let's check this magic weapons get name. Well, it calls as the basic items get name, but it should be different at that point, shouldn't it? Right, that's what you might think. Well, let's walk through and see what this is doing. So we're gonna put a breakpoint there. Let's run this. All right, so far our weapon is still named basic sword. We're gonna call set name on this magic weapon, and let's see what it goes into. It goes into the set name from the base item and operates on the base item. So we'll now see that this basic weapon is still named basic sword, but this one that it copied in, because if we look at this decorator, it just takes a pointer and then it does this operation. So the question is, what is this doing? And the answer seems to be that it's making a copy of the weapon by some means here. If we look at magic weapon now, we see that it has the name Armageddon. So, but this root item one is called what? Still basic sword. So we would think that we overwrite the original, but it appears we don't. And the reason is because how we're calling this set name. So basically, I'm pretty sure this has to do with how the function table works, because essentially when we're calling get name here, we're using whatever item it is. However, we don't have it casted. We don't know what type it is. We don't know if it's armor or not, but essentially they do the same thing. They override the name, and you can see it's still get name even after we move past this section. Or let's see here. We look at this magic weapon, look at how everything's set, check out the item underscore. We see that its name there is basic sword, even though it shouldn't be. But if we go look at this one's item type, its actual name is Armageddon. And why is that? Well, because, well, this is also inheriting from item. This magic decorator is inheriting from item. So it also has that same function along with item. So the function's in there twice. If we call it on the base one, then we're getting the base name. If we call it on the on this actual decorator, then it's different. So this get name should not use this if we wanted to get the name from this actual class. So that's where it gets a little confusing here. So if we call this get name here, it's going to recursively call what would now be this function. And we don't exactly want it to do that. We want to call the base version of it. But let's give this a run and just see what it does. We'll put a stop point here and let's see what this does. Now, is this going to be recursive, or is it going to call the root one? That's the question we want to answer here. Here we go. We call get name. Let's go into it, and it looks like it recursively goes into the same one. So that's not what we want. So the question is, how do you get this to call specifically what's being inherited if you want, rather than whatever you're setting? Because, well, we know how to set this one. We know how to call it like so, but that doesn't seem to get us the right name. It doesn't get us the one that we're accidentally setting here. Well, basically what we end up needing to do is override this set name function here, but we don't make it equal 0. So you don't have to override it. If not, you just get the default one. But in this decorator, we want to override it. We don't want to override it in the concrete ones. It's fine there. But in this one, we do. So let's go ahead and do that real quick. Like so. Virtual void set name override string reference there. New name here. And we will say item name equals new name. Now it's going to complain about something that we don't have access, basically. So we have to call that item's set name on this new name. And let's see what happens here. Now, is this going to recursively go into set name, or is it going to magically fix everything? Let's take a look. And I already know the answer, but this will be interesting. So we go into set name. It calls this root one and sets the root name. And now when we export these, do we get the correct name once it's magical? And the answer is yes, we do. But what happened here? We no longer got a name out of this. Or yeah, we did, but it was the wrong name. It actually changed weapon 1 for real this time, basically. So I guess the point here goes a little deeper. Ooh, let me continue on through this. There we go. And then we got the magic version there. But the basic version should still say the basic version, right? It shouldn't change its name when we call magic weapons set name. Now that's we're kind of getting into another theory loop here, because now it's a question of, well, if it's just a plain old item, does it, like an unknown, unidentified item, does it even have a name yet? And the answer is probably no. So we probably want to get rid of some of these and do this a different way and give it different root stuff, or just default its name to unknown and let other classes handle the implementation of set name entirely. But the point is, we don't want to necessarily modify the name of the base item. If it's magical, it kind of gets a new name, basically, because this one down here is going to be its root name. So maybe we want another string for like custom name here, or like, you know, like a magic name. I guess it will just be magic name. Let's stick with putting the underscore here. And in that case, we would do something different with this set name when we're in the magic decorator. Basically, we just go like this: magic name equals name. And so in this case, now when we call get name, we need to decide, well, this original one is going to call whatever the item inside is, but we might just want it to be magic name. And this magic +2, whatever it is, get item type, this will be a little different. Because, well, we could customize it with its name. If we want to put the type in there, we can. But I kind of feel like it'd be cooler to say, I'll get rid of this magic. We just have a plus or a minus if it's magical, basically. And then we have the modifier. And then we have the string. But instead of the string, let's go, let's add something else here. We want its original name. Item. So this should get like basic sword. It'll say like a +2 basic sword. Now, Armageddon, the +2 basic sword. Another space here. And maybe we'll keep that item type there at the end because we, you know, ideally this would be in its own little section, you know, like maybe have an icon and it says armor or weapon on it somewhere. So this is kind of what that's for, but getting a little odd at this point. Okay, let's hit play on this. Got a broken thing. What do we got here? Just a syntax error, it looks like. Yeah. Okay. There we go. I think we're going to go ahead and just disable all the breakpoints and run it and see what our output is and see if we get what we expect. And we do. Basic sword is fine. But now Armageddon is a +2 basic sword. And we got its type there, weapon, and then the damage was a separate C out there on our main, like that. But as you can see, get name on weapon just did basic sword. Get name on the magic weapon no longer tries to modify the basic weapon's name. So maybe there's some special consts you want to put in there for those situations, which I didn't really do. But we worked around it anyway. We got its special name there. We got its modifier. We got what it originally was. And that it's a weapon. So that's getting into the thick of it with decorating in a dynamic fashion. See if you can figure out how to do this statically if you want a good challenge, if you kind of understand this. And the way to expand this further, which, you know, would take a lot of over explaining once again, is basically you make other decorators. And since this magic decorator is also an item, you could magic a magic thing and just keep going. For example, we could go once again another magic decorator and call it like, I don't know, X2 magic weapon. If it got enchanted once again, and we pass in here this original magic weapon. Since it's an item, it is legal, and we can do that. Let's put another modifier of 2 on there. But now we're going to have to consider that because we got a cascade of things. Could potentially get pretty wonky. I don't know. Let's just do a final display of this X2 one. This get damage is, let's see here, not virtual or anything. Yeah, we should be able to call, well, we have to call this on a concrete weapon. So that's like, maybe get base damage is a better name for that. We get the base damage, whatever weapon it's coming from. So this isn't super intuitive to get the damage, I guess is the point, which is sort of weird. We should probably put a function in these magic decorators to handle that, but it's going to take some more dynamic casting and checking, and that might be a good thing to see if you can figure out, how to make it so that you call this get damage. Like if you want to get the damage of the X2 weapon, you should be able to call get damage, and it should get it all properly without needing a reference to the original one right there. Anyway, that would be the further extension. And here we go. We've got a cascade effect going on. You see it's a +2 basic sword, it's Armageddon, and then it's got a new name again, which we didn't fill out. But it looks like it casted eventually to unknown because our cast check in this magic decorator on the get item type, it's only looking for concrete armor and concrete weapon. It's not looking for magic decorators too. So that's kind of a cascade we don't necessarily want, but it is possible just because of the way that the magic decorator is also an item. And that's essentially how you can start working up adding, what am I trying to say here? I guess just cascading effects. Now we're obviously constructing here, but what you could do is you could put functions within your decorators or within a concrete one to allow setting certain properties and identify them that way, which is kind of beyond the scope of this, would be another level. So I don't know, maybe if we ever get to designing an actual proper game, I'll be able to make examples and then show you how it works in game. But since this is a wild, undirected example, we're going to leave it at this, and hopefully that helps it make sense and you can see how you can cascade stuff. Another next step would be to use the move operation on this stuff so that we actually move it in, kind of like that web page auth we did in part 1, because that would do some different things as well. All right, well, as you can see, there's a lot you can do with decorators, and if you've got that giant hierarchy, something like this might start working better depending on how you're organizing things. That's basically the entire point. All right, thanks for watching. I'll see you guys on the next one.